Welcome to Chemistry 351 Physical Chemistry at Binghamton University for the fall semester 2013. My name is Jim Dix. I'm a faculty member in the chemistry department. I've been there for 31 years. For the past 30 years, I've been teaching traditionally. That is, I go to lecture, speak some things, students take notes, and then the process is repeated for about 45 times during the semester. This semester, I'm going to teach physical chemistry quite a bit differently. What I'm going to do is to teach the course as a flipped course. What is a flipped course? Well, here's a short Wikipedia article on flipped teaching. Essentially what it is instead of me going to class and lecturing, I instead record all my lectures online and put them out on what I'm going to use as YouTube. You then, as students, will watch the lectures online before you come to class. Classroom time will be used then to discuss things that are online, to go over some problems. We'll have clicker questions and things like that. So it's a flip, sort of, instead of coming to class to hear me lecture, and then after class do problems and discuss. After class, or not during class, you will listen to lecture online and then come to class and discuss and do problems and things like that. So we're going to see how that works. Various studies have shown that this is actually a better way to teach, and we'll see whether it works in physical chemistry this semester. So lectures will be recorded and put on YouTube. Okay, and then the links to the YouTube videos and lecture slides and notes will be put on Blackboard. So anything that I'm writing here, any notes that I write and so on, will be both in video and in hard copy as PowerPoint, actually probably PDF or maybe PowerPoint slides also. Okay, the classroom time then will be used for your questions, for IClicker questions, discussions, and so on. What does this mean? This means that you will be responsible, you as students will be responsible for viewing lectures before coming to class. So for example, if we're on the third lecture, you will come before the third classroom time, you'll come and prepared by having listened to the YouTube video. Okay, hope that's clear. If not, bring questions for the first class. All right, a few words about Chemistry 351. It's required for Chemistry BS majors. So every Chem BS majors, you have to be in this class. You have to eventually take this class. This is one of two required courses for Chem BS. The other, you have your option of Chem 451, which concentrates on quantum mechanics, or 452, which concentrates on thermodynamics. If you are a Chemistry BA major, this is one of the two options you have to satisfy your one semester physical chemistry requirement. The other option is to take Chemistry 361, which is physical chemistry with a bent toward biology. It's biophysical chemistry, one of the two options. Now, there are three parts generally to introductory physical chemistry: thermodynamics, quantum mechanics, and kinetics. Those are the three biggies. So if you go to, say, the American Chemical Society required topics for physical chemistry, they have these three topics. However, if you actually look at an introductory physical chemistry textbook, there's a fourth topic, statistical thermodynamics, which is also covered. We will be concentrating on these first three topics in physical chemistry in this course, and we will also have a couple lectures on statistical thermodynamics. If you want to learn more about statistical thermodynamics, take Chem 452. If you want to learn more about quantum mechanics, take Chem 451. Okay, class times: Monday, Wednesday, Friday, 9:40 to 10:40. At UU 206. I'm trying to get that changed to a classroom closer to Science 2, but until that happens, we'll meet in UU 206. There's a fourth meeting time. That's Wednesday from 7 to 9. That will be in Science 1, room 140. That meeting time will be used for exams and for extra class time as needed. For the first week of class, we will not meet during Wednesday from 7 to 9. Instead, we will meet once on Wednesday, 9:40 to 10:40, UU 206. The first class will be Wednesday, August 28th at 9:40, and there'll be no Wednesday PM class in the evening. All right, so note that you don't come to class the first day of class. Instead, you should be going online and looking at the first lecture. And then when you come to class on Wednesday, if you have questions about that first lecture, then go ahead and do it. Go ahead and ask questions. The links for the YouTube would be posted on YouTube lectures will be posted on Blackboard. Okay, what do you have to know before getting into this course? First is, of course, General Chemistry, Chem 107, 108, or Chem 111. Also required for this course is Physics 1, either 121 or 131. Physics 2 will be handy to have, but physics topics that are not covered in Physics 1 will be introduced as needed during this course. Also, you're required to have Calculus. That's Math 221 and Math 222. Physical chemistry uses a lot of calculus. We will actually be using quite a bit of calculus, and therefore I've noticed in the past students are a little rusty on calculus. We'll review that as needed. And also physical chemistry has calculus as several variables. That is sort of touched upon in Math 221, Math 222. But again, we will, as we need concepts, introduce them and during the course of the semester. All right, what kind of textbooks do you need? Well, you need an introductory chemistry textbook. Here's one, Ball. That's what I've used in the past. My hope is that there'd be a lot of used copies or copies you can borrow so you don't have to pay $150 for the textbook. Another possibility is Atkins and DePaula, the 8th or 9th edition, or any other recent physical chemistry textbook. All right, so let's take a look here. Here is Ball, Physical Chemistry. This is what this looks like. It's actually 2002. Physical chemistry really hasn't changed much in the past probably 50 years. But if you want to use this, I guess you can rent them or find one to borrow, or you can even do Kindle if you're into that. Here's what Atkins and DePaula looks like. Go away. It looks like this. You can rent that. You can find it used or so on. The 8th or 9th edition would be good. Here is a textbook also by Atkins and DePaula. It's called Elements of Physical Chemistry. Elements of Physical Chemistry. That would not quite be suitable. That's like baby physical chemistry. So don't be confused by the Atkins and DePaula Elements. If you want to get one that'll be suitable for this course, just get the one that's called Physical Chemistry. All right, so we need an introductory physical chemistry text. Doesn't really matter which one, they're all about the same. If you have questions on a textbook, bring it to the first class on Wednesday, not Monday, Wednesday, and ask questions about whether it's suitable or not. The second suggested thing is Preparing for your ACS examination in physical chemistry, the official guide. This is published by the American Chemical Society, Division of Chemical Education. And here's a link for it. You don't have to write down this link since this PowerPoint slide will be posted. You can just copy and paste. What is that? Why is that interesting? Well, we'll go into it in a minute, but the final exam for this course is the Standardized American Chemical Society Physical Chemistry exam. That's the final exam. And so if you want to study for the final exam, which will count 25% towards your grade, this is a good book to do it. Also, it's also a good book just to sort of get a different perspective on physical chemistry. Sometimes a topic might not be very clear in one textbook or in lecture, but then if you go to another textbook, it might become more clear. So the ACS study guide looks like, well, you have to go to the American Chemical Society. $21, not too bad. Designed for use for any physical chemistry exam, including thermodynamics, kinetics, and quantum chemistry. Those are the three things that the American Chemical Society thinks there should be in introductory chemistry courses, but in fact most textbooks include statistical thermodynamics also. So you can purchase it online. Maybe Amazon also has that. There'll be a copy on reserve in the science library also, or in the reserve room. Okay, so those are the two texts we suggest to use for this course. Grading. Well, there'll be 3 exams spaced about equally throughout the course. That'll cover 70% of the grade. The exams I give are open notes, open book, computers, and so on. Whatever study guide you think will help, you bring that along to the exam. The only thing that's not allowed, of course, is talking to people who are taking the exam, but also no internet access is allowed during the exam. So you can bring your computer, but you cannot use the internet to chat with other people or to look up answers or things like that. So only things that you take or are distributed should be used. No internet allowed. Then, as we said, the final exam will be the American Chemical Society standardized exam for physical chemistry. That'll count for 25% of your grade. The final exam is mandatory. It's not optional. And the final exam will be closed book in contrast to the 3 open book exams given during the semester. All right, and the last part is these IClicker responses. For those of you who have been at Binghamton for a while, you probably know what IClickers are. If you're a transfer student and this is your first semester, IClickers are essentially a device that you can press A, B, C, D, or E, and that is in response to a multiple choice question that I put up. And your grade will be based not only on coming to class, but also whether you get the question right or not. So it'll be half and half. But 2.5% will be whether you come to class, which will be whether you press the clicker or not. And then second 2.5% will be whether you get the right answers or not. A little bit more about IClickers. You need by class on Wednesday. The first day of class is not Monday, but Wednesday. If you don't have one, you could purchase it at the university bookstore, or probably online also. Once you get your clicker, you must register it here. If you only need to register it once for all the courses you're taking. So if you already registered for another course, you don't need to do that again. And the IClicker questions will be given during classroom time. They won't be given in the online lectures. IClickers I found actually are good to see whether I get a particular topic or particular point across, and often I'm flabbergasted that something I don't think I explain very well, students, as judged by the IClicker responses, understand it perfectly, and things that I get across crystal clear, students don't understand at all. So it helps for me to see whether the online lectures and the discussion in classroom are actually having any effect. So IClickers are useful. All right, how have been grades in the past? Well, let's look at last year. Last year, 29% got A's and A minuses, 32% got B's, and 31% got C's. So it's a pretty flat distribution across there, equally divided by A's, B's, and C's. If you look at the lower grades here, you'll find that although some people do fail the course or get a D in the course, it's not very many people. So usually by the first couple weeks of class or by the withdrawal deadline, you know pretty much how well you're doing, and students who are getting these lower grades withdraw. But typically you get a flat distribution. However, there have been some years in which the students, for some reason, have really good aptitude for physical chemistry. Let's look at 2007. Here, 48% of the students got A's and A minuses, almost half the class, which is virtually unheard of in physical chemistry classes. And also 2006 was an exceptional year. We got 43%. So, a lot of times, usually it's about equally distributed, but there's also a chance here. So my hope, of course, is always that the class will do even better than the 2007-2006 classes. We'll see how things work out this time. Anyway, pass grade distributions. I grade on a curve, and the curve is set pretty much based on what I think you should know. The average of the exams are around 50 to 60%, which is, well, 50 to 60% would be a B here. Here be probably an A minus. Okay, questions about past grade distributions, bring them to the first class, which is Wednesday, not Monday. Let's take a look at the syllabus. Here's the syllabus. We went through all this stuff already and so on. Let's look at the schedule here. You see we have 3 exams. Exam 1, 2, and then down here is exam 3. The first law of thermodynamics, second law of thermodynamics, phases and mixtures, that's all thermodynamics. So thermodynamics, that will be the first part of the course, and that's primarily what exam 1 will cover, probably all of it. Then there's quantum mechanics, introductory to quantum mechanics. We talk about that. Exam 2 will be on quantum mechanics. And then we continue quantum mechanics after exam 2, have our couple of lectures on statistical thermodynamics, and then get into kinetics. So exam 3 will be leftover quantum, a little bit of statistical, probably one question on that, and then kinetics. Okay, there we go. And then the final exam will be Wednesday, December 18th, 2000. Better check this. Not quite sure. This might be from last year's syllabus. Okay, and then here's some topics here for the ball chapters, but also there are, in addition to the ball chapters, first law of thermodynamics. Just look. If you look at look at the table of contents of any introductory mainstream physical chemistry course, it's all about the same. So chapter 2 in Ball is probably chapter 2 in Atkins and Paula. Here's some learning objectives. This is what we're actually going to try to learn during the semester. That's all in the syllabus, and this will be posted online on Blackboard probably by the time you get to class, or before you get to campus. Okay, 2 other items here. Academic honesty. Look at the statement on academic honesty in the university bulletin. Make sure you review that. Let's take a look at it. Here it is. Let me get it up here. All right, here's the resources for students here, academic advising, academic assisting, academic honesty. Here it is. So click on here, you go to the academic honesty policy. Review this. Okay, the whole thing about academic honesty is you shouldn't cheat, and one of those things that I really don't like are people who cheat in class. And so all cases of academic dishonesty will be prosecuted. I have 2 options. One is to have you sign a paper saying you'll never do it again, and if you haven't done it before, that's the end of it. The second option is to bring you before an academic honesty committee, and I will take that second option if I find evidence of academic dishonesty. So bottom line is don't cheat. Here's some important dates. If you want to drop the course or add the course without consequence, September 16th, Monday, September 16th is that date. If you want to withdraw from the course, and a W will appear in your transcript, Friday, November 1st is that deadline, and Friday, November 1st is also the deadline for a change of grade option when you go pass-fail instead of for a letter grade. Those are important dates. Final topic here, recording and copying and distribution of course materials. All right, so you may record, copy course materials for your own personal use. However, you may not sell course materials online. That is to say, you can't take my brilliant lectures and try to sell them online, or anything I create for this course. So you can use it and copy it, but you can't sell it. That's basically it. So that's the introduction. The next online lecture we'll start right in with thermodynamics, the first part of physical chemistry.